Want a holiday gift your employees or clients will actually love? Send them gourmet peanuts from Hubbard Peanut Company. Hub's Peanuts is a family-owned company that's been making high-quality, delicious peanuts and sending them to every corner of the globe since 1954. Order some of Hub's plain, salted, or chocolate-covered peanuts in a special gift tin for the perfect gift for your friends, employees, clients, or even yourself. Visit hubspeanuts.com. That's HUBS peanuts.com.
Hello, Saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
This is SpaceTime Series 23, Episode 71, for broadcast on the 13th of July, 2020. Coming up on SpaceTime, a stellar graveyard in the Galactic Center, NASA's Mars Curiosity rover begins the next part of its journey through the foothills of Mount Sharp, and Israel launches a new spy satellite. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have discovered a stellar graveyard near the centre of the Milky Way galaxy containing the corpses of at least 27 stars. The findings, reported in the publications of the Astronomical Society of Australia, include one star that went supernova in a vast empty region of space just 9,000 years ago. Scientists using the Murchison Wide Field Array radio telescope in outback Western Australia made the discovery while surveying the Milky Way's galactic centre. The data was then processed using the Pawsey Supercomputing Centre in Perth to create a spectacular new map of the sky as part of GLEAM, the Galactic and Extragalactic All-Sky Murchison Wide Field Array Survey. One of the study's authors, Dr. Natasha Hurley-Walker from the Curtin University node of the International Centre for Radio Astronomy Research, says this new view captures low-frequency radio emissions from the Galactic Centre at frequencies between just 72 and 231 megahertz. It provides both fine detail and larger structures with resolutions of 2 arc minutes, which is about the same as the human eye. And this allowed astronomers to disentangle different overlapping objects, separating out and making sense of different complex structures. Essentially, different objects have different radio colours, which can then be used to work out what's happening. And using the images, Hurley-Walker and colleagues discovered the remnants of 27 massive stars which had exploded as supernovae at the end of their lives. Each of these stars would have been at least 8 times more massive than the Sun before their dramatic destruction thousands of years ago. Younger and closer supernova remnants, or those in very dense environments, are easy to spot, and so far astronomers have identified more than 295 of them. But unlike other instruments, the Murchison Wide Field Array can also find those which are older and further away, or in very isolated regions of space. In fact, one of these newly discovered supernova remnants lies in such an empty region of space far away from the galactic plane that despite being quite young in astronomical terms, it was incredibly faint. In fact, it's the remains of a star that died less than 9,000 years ago. That means the explosion would have been noticed by ancient people on Earth at the time. Hurley-Walker says 2 of the supernova remnants discovered are quite unusual orphans found in a region of sky where there are no massive stars, which means future searches across other such regions may also wind up providing some interesting new discoveries. The Murchison Wide Field Array is a precursor to what will be the world's largest radio telescope, the Square Kilometre Array, construction of which is due to begin in Australia and South Africa next year. The low-frequency part of the SKA will be built on the same site as the Murchison Wide Field Array, but it will be thousands of times more sensitive and have even better resolution. Hurley-Walker says this new technology will allow her to find thousands of new supernova remnants that formed within the last 100,000 years, even if they're way on the other side of the galaxy.
So we use the Murchison Wide Field Array, which is a radio telescope out in the Murchison region of Western Australia. And the real power of this telescope is it has a massive field of view and an amazing frequency bandwidth. So we can observe all across the radio spectrum, and we can see most of the galactic plane all at once. So this is part of a big survey called the Galactic and Extragalactic All-Sky MWA survey, which, as the name implies, is part of the whole sky. So this is a specific data release which is part of the sky that covers the galactic plane. And the reason that we've done this specifically is because the galactic plane has structures on small scales, on medium scales, and on big scales that stretch right across the sky. And so to create the images that you might see, we needed to use really powerful supercomputers and quite clever algorithms to properly create those images and get all of the brightness in the right places. So doing that across this very wide bandwidth has given us this beautiful image of our own galaxy, all the way from 72 megahertz to 231 megahertz, which gives us a really interesting view of the universe. So the sorts of phenomena that we're seeing in here are the remains of exploded stars. So when a star ends its life, it creates a huge explosion that moves outward, and that makes this big spherical shock wave. And that's visible in the radio, a bit like a sort of soap bubble suspended in space. And that persists for tens to hundreds of thousands of years, whereas the original explosion is pretty much gone in a month. So this allows us to look right back in time across tens to hundreds of thousands of years of stars living and dying in our galaxy. And there's a whole host of other things you can do with the data as well.
With these supernova remnants, they can be spectacularly beautiful to look at, but they also tell you a little bit about the galactic history of that region of space too, don't they?
The explosions that create supernova remnants are pretty well understood because the kinds of stars that collapse to form supernovas are typically the hot, bright stars, and we think we understand that population and the way that they explode. But then once the shockwave starts going out into the galaxy, its progress is really changed by the kind of gas and space around it.
The interstellar medium.
The interstellar medium, exactly. So if it's in a dense region, then it will go more slowly and it will be more bright, whereas if it's in a diffuse region, it will be faster and it will be less bright. So one of the interesting things that we found in this research was two supernova remnants in a region which is completely devoid of massive, hot, bright stars. And that's kind of unusual because the lifetime of those hot, bright stars is quite short, only a few 100,000 years. So for these explosions to have happened in this region where we don't really see any of these other hot, bright stars is sort of a surprising result. And they're both very faint, and they both look like they're expanding into very diffuse gas. So it's a little bit of a puzzle because nobody expected to see these. And so, we're following them up. There's actually two parts of the data release. There's the beautiful galactic center region. There's also a sort of quieter area on the other side of the galaxy, which I've also released. It's not quite so exciting, but that's where the two very faint objects were found. It's also important to remember that the telescope has a massive field of view. So when we think of the galactic center, we're often thinking of just a few square degrees right around the central supermassive black hole. But we're seeing the whole region around the center. So it's an 8,000 square degree data release. And so that covers regions that are very dense and very close to the plane, but also further outward. One of the objects that I found was actually nearly 10 degrees off the galactic plane. And again, it's expanding into a sparse region. And so the shell is very faint. It's this very small bubble. But we do have a pulsar measurement from right in the middle of that object. And a pulsar is the other part of a supernova remnant. So when the massive star explodes, the shell goes outward, but also some of the mass falls back inward and can create a very, very dense, rapidly spinning neutron star. So in this case, we've seen the neutron star, so we know the distance, essentially. We can work out how the pulses of that star are changed by the electrons between us and the pulsar. So we can work out the distance, and that means we can work out the size of the supernova remnant. And that's really critical because without the size, it's hard to tell whether it's a small thing that's close by or a big thing that's far away. Once we've got the size, again, using the physics that I talked about earlier, where we know how these hot, bright stars explode, we can work out how old it is. And what's fun about this one that I found 10 degrees off the galactic plane is that it's only about 9,000 years old. and it sits just below the constellation of the Emu, which is an important constellation for the indigenous people of Australia. And if is only 9,000 years old, then it would have been visible to people living here at that time. So that's really fascinating, and I'm working with indigenous astronomers to follow that up and see if we can find any record in oral tradition.
The fact that these pulsars, these neutron stars, were born in this very sparse region of space, that's unusual.
It's a little unusual. I had to make some calculations when I was doing this work to see what were the chances of just happening to find a pulsar in the middle or even within the shell of any of these remnants. And as you get close to the galactic plane, the population of neutron stars also increases. And so you get to quite a large chance that there could just be a coincidence. And so it becomes hard to make those calculations. But as you go further off the plane, the density of both decreases, both the remnants and the neutron stars, sort of as you'd expect. And so the chance of coincidence becomes smaller. But there are still neutron stars, there are still pulsars in all directions in the sky, because we are inside the galactic plane. It's not something that's separate from us. We're right inside it. And so if we look, up, down, behind us, towards the center, wherever we look, we do still see pulsars. With just more of them towards the center of the galaxy.
So it's just part of the normal distribution of stars that you find in the galaxy anyway?
Yeah, pretty much. The nice thing is that as you're not looking towards a very confused region, it's easier to be sure that you've made the correct association, and the chance of coincidence goes right down. That will be really interesting in the era of upcoming very sensitive radio telescopes like the SKA, where we should be seeing pretty much all of the pulsars and all of the supernova remnants after a few years of that telescope at work. And then we'll actually have a complete census, but we'll still have the problem that it will be difficult to associate things in these really complicated regions.
That's Dr. Natasha Hurley-Walker from the Curtin University node of the International Centre for Radio Astronomy Research. And this is Space Time. I'm Stuart Gary. Still to come, NASA's Mars Curiosity rover moving to its next location on the Red Planet, and Israel launches a new spy satellite to monitor the growing nuclear threat being posed by an ever more militant Iran. All that and more still to come on Space Time. Okay, let's take a break from our show for a word from our sponsor, ExpressVPN, rated #1 by TechRadar. You may be wondering why you need a virtual private network. Well, it's in the name. It's all about privacy. Do you really want big brother tech companies, hackers, governments, and who knows who else snooping in on your online activities? Now, you might not have anything to hide, but it's still really creepy, and it could be dangerous for you and those you care about. Also, how often do you run across a website and you want to get information from it, but you find out that they're geo-blocked? It's all very frustrating, and it's becoming an increasing problem. And that's where ExpressVPN can help you. ExpressVPN's a simple and efficient way to protect your online privacy. It's internet without borders from the world's leading VPN provider. So, protect your online privacy today. And find out how you can get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Visit tryexpressvpn.com/space to learn more. And of course, you'll find the link details in the show notes and on our website. That's tryexpressvpn.com/space. And now, it's back to our show.
You're listening to SpaceTime with Stuart Gary.
Well, after more than a year of exploring the so-called clay-bearing unit at Gale Crater, NASA's Mars Curiosity rover has started the next phase of its journey, a journey that will take it higher up through the foothills of Mount Sharp on the Red Planet. The roughly 1.6-kilometre long trek will take the 6-wheeled car-sized rover around some deep sandy terrain, positioning it to ascend the next section of the 5-kilometre high mountain it's been exploring since 2014. Curiosity is searching for the conditions that may have supported ancient microbial life on the Red Planet. Located on the floor of Gale Crater, just north of the Martian equator, Mount Sharp is composed of sedimentary layers that have built up over time. It's like a geological textbook of Martian history. Each layer helps tell the story of how Mars changed, from being a warm, wet world with a thick atmosphere and Earth-like liquid water lakes, streams and an ocean, through to the freeze-dried desert it's turned into today. The rover's next stop is a part of Mount Sharp known as the sulfate-bearing unit. Sulfates, like gypsum and Epsom salts, usually form around water as it evaporates. And they provide yet another clue about how the climate and prospects of life on Mars changed nearly 3 billion years ago. But between the rover and those sulfates lies a vast patch of sand, which Curiosity needs to drive around in order not to get bogged, hence the 1.6-kilometre detour. Mission managers who are commanding Curiosity from their homes rather than their offices at NASA's Jet Propulsion Laboratory in Pasadena, California, expect to reach the area in September, although the science team could decide to stop off along the way to drill for some samples and study some surprises they come across. Depending on the landscape, Curiosity's top speeds will range from 25 to 100 metres per hour. Some of the road trip will be completed using the rover's automated driving abilities, which enable Curiosity to find the safest path forward on its own. But Curiosity can't drive entirely without humans being in the loop. It does have the ability to make simple decisions along the way in order to avoid large rocks or risky terrain. But it stops when it doesn't have enough information to complete a drive on its own. In journeying to the sulfate-bearing unit, Curiosity leaves behind Mount Sharp's clay-bearing unit, which the robotic scientists first began investigating on the lower side of the mountain way back in early 2019. See, scientists are interested in the water environment which formed this clay and whether it could also have supported ancient microbes. Extending across both the clay unit and the sulfate unit is a separate feature, the green hue pediment, basically a slope with a sandstone cap. It's thought to represent what was a major transition in the climate of Gale Crater. See, at some point the lakes which filled the 154-kilometre wide crater disappeared, leaving behind the sediments which ultimately eroded into the mountain we see today. The pediment, however, formed later, through weathering from either wind or water erosion, or maybe both. Then wind-blown sand blanketed its surface, building it up into a sandstone cap. The northern end of the pediment spans the clay region, and although the slope is steep, the rover's team decided to ascend Greenbarrow back in March in order to scope out the terrain they're likely to encounter later in the mission. As Curiosity peeked over the top, the scientists were surprised to find small bumps of nodules along the sandstone surface. Now, these nodules required water to form, so sometime after the pediment formed, water must have returned, altering the rock as it flowed through it. And that's interesting because one of Curiosity's predecessors, the Mars Opportunity rover, found similar geological features which have been dubbed blueberries during its journey back in 2004. Nodules have become a familiar sight throughout Mount Sharp, though these newly discovered ones are different in composition from what Oppie found. They suggest that water was present in Gale Crater long after the lakes disappeared and the mountain took its present shape. It's a discovery which extends the period during which Gale Crater hosted the sorts of conditions which would have been capable of supporting life as we know it. This is SpaceTime. Still to come, Israel launches a new spy satellite, and later in the science report, growing fears that the world's tropical plant species may struggle to germinate by 2070 because of global warming. All that and more still to come on SpaceTime. Israel has launched a new reconnaissance satellite to monitor the growing nuclear threat being posed by an ever more militant Iran. The OFEC-16, OFEC being Horizon in Hebrew, was launched aboard a Shavit 2 rocket from the Palmashim Air Base on the Mediterranean coast south of Tel Aviv. The spy satellite is the latest in a growing constellation launched by Jerusalem to monitor the Islamic Republic, which has repeatedly threatened to attack the United States and to obliterate the Jewish state. The new OFEC-16 electro-optical reconnaissance satellite is equipped with a 120-kilogram, 1.5-metre long, multispectral high-resolution Jupiter space camera with a 700mm aperture, providing a resolution of better than 50 centimetres from an altitude of 600 kilometres. The new spacecraft can monitor and photograph a 15 square kilometre wide footprint as it circles the Earth. The mission marks the 11th launch of a Chevette rocket, although several smaller-sounding rockets with the same name were launched by Israel in 1961 on scientific missions. The Chevette, or Comet in Hebrew, are built by Israeli Aerospace Industries as a 3-stage solid-fueled rocket with a liquid-fueled 4th stage available, depending on the payload and mission. The 27-metre-tall rocket is designed to carry 800-kilogram payloads into low Earth orbit, launching retrograde, that is, west over the Mediterranean Sea, so as to avoid flying over and dropping spent stages onto populated areas. Most rocket launches are towards the east to take advantage of Earth's rotation. The Chevette launch vehicle is actually based on Israel's 14.2-metre-tall Jericho-2 solid-fueled 2-stage ballistic missile. The Jericho-2 is designed to carry a 1,000-kilogram warhead. An updated version, known as the Jericho-3, is understood to be even more similar to the Chevette-2, with 3 stages, just like the Chevette-2, and an upgraded 1,300-kilogram payload capacity. According to a 2004 missile proliferation survey by the United States Congressional Research Service, the Jericho-3 has a range of 11,500 kilometers. Israel's armada of intercontinental ballistic missiles are believed to be buried in silos so far underground they'd survive a first-strike nuclear attack. Interestingly, the Chevette-2 was also produced under license from Israel in South Africa, both for space launches and ballistic missile tests. 3 suborbital flights were carried out from the Oberg Test Range, 200 kilometres east of Cape Town, in June and July 1989 and November 1990. However, after Johannesburg cancelled its nuclear weapons program in 1989 following the production of an estimated 6 atomic bombs, it halted its ballistic missile test and space program in mid-1993. This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with a science report. A new study warns that half of all the world's tropical plant species may struggle to germinate by 2070 because of global warming. Scientists with the University of New South Wales found that tropical plants close to the equator are most at risk from climate change because it's expected to become too hot in the next 50 years for many species to germinate. The findings, published in the journal Global Ecology and Biogeography, analysed almost 10,000 records from more than 1,300 plant species from the Kew Gardens Global Seed Germination Database. Patients with COVID-19 may also be at a higher risk of stroke, according to a study which looked at 3,402 patients at 2 hospitals in New York City. The findings, reported in the Journal of the American Medical Association, compared patients with COVID-19 at these hospitals to patients with influenza, which is another respiratory virus known to be associated with stroke. The authors found that patients with COVID-19 appeared to have a higher risk of stroke than those with influenza, suggesting a significant stroke risk for those with COVID-19. Well, if you have kids, you probably already know about the popular video sharing app TikTok. However, there are now growing calls to ban the app, which has over 1 billion users worldwide, because of serious security concerns. There are 1.6 million TikTok users in Australia alone, mostly teens and young adults. But the Australian government is now looking at TikTok security issues. Federal Member of Parliament George Christensen has called for banning TikTok along with other Chinese applications such as WeChat. The application is already prohibited on both Australian and American military-issued devices. And US Secretary of State Mike Pompeo says Washington's also considering banning Chinese social media applications, including TikTok, over national security concerns. Pompeo says people should only use TikTok if they wanted their private information in the hands of the Chinese Communist Party. In fact, India has now blocked access to 59 Chinese-owned smartphone applications, including TikTok, for stealing and surreptitiously transmitting user data. Like many other apps, TikTok collects user data, including details about you, your likes and dislikes, your smartphone, your contacts, your work, and your location. Concerns about the app were first raised back in January following complaints over child safety, when it was discovered that TikTok exploits a vulnerability loophole in Apple's copy and paste program, although researchers admit they're not sure exactly what the company's up to. Then the following month, a new security report warned that data copied onto clipboards on iPhones and iPads was being seen and accessed by the app. Now, that information might just be your shopping list, but it could also be your bank account details, passwords, whatever. And the logs show that TikTok's reading this content whenever it's opened, even if that content's been deleted. Again, no one knows why it's reading it, just that it is. Security experts claim it seems to be all part of a greater Chinese Communist Party Stasi-like program to simply gather as much data on people as possible. However, the Beijing-based company ByteDance, which owns TikTok, says it doesn't send any user data to the Chinese government. But then again, China's 2017 national intelligence law compels individuals and companies to assist the Chinese Communist government by providing access, cooperation and/or support for any and all intelligence gathering activities. Scientists in the United States have debunked the well-known rule of Poor that 1 dog year is equivalent to 7 human years. Instead, a report in the journal Cell Systems claims researchers have devised a more accurate formula for calculating your pooch's age based on the chemical changes in doggy DNA as they grow older. The team studied 104 Labrador retrievers, spanning from few-week-old puppies to 16-year-old old-timers. Now, based on the new formula, an 8-week-old puppy is about the same age as a 9-month-old human baby. And the average 12-year lifespan of Labrador retrievers corresponds to the worldwide life expectancy of humans of 70 years. A new study shows that communities on Facebook that distrust establishment health advice are more effective at getting their message across to undecided individuals than doctors and government health agencies. The research by George Washington University and reported in the journal Nature tracked 100,000 online conversations about vaccine use during the 2019 measles outbreak. They found that while there were far fewer anti-vaxxers on Facebook than those who saw benefits in vaccination, there were nearly 3 times more anti-vax communities on Facebook compared to pro-vaccination communities. Tim Mendham from Australian Skeptics says this allows anti-vax communities to become highly entangled with undecided communities, while pro-vaccination communities remain mostly peripheral.
What this says is that there's actually ultimately a lot fewer people who are, say, anti-vaccination people than there are pro-vaccination people. As we know, that 95% of kids are vaccinated in Australia, so there's a lot more people who support vaccination than don't. And yet the deniers, the anti-vaxxers, are very loud, especially on areas like Facebook. These researchers tracked a lot of conversations, if you like, that were on Facebook, actually about the measles outbreak, which was in 2019, and they created what sort of looks like maps of how they interact with each other, and they're certainly in clusters of belief systems, and may even be in clusters of geographically, which worries me a bit about the researchers, that they know where people are. That's a concern to me. But it's also the fact that because these are in clusters and they do talk to each other, that they have a greater influence than they should do, especially considering their lack of expertise and their low numbers, relatively low numbers. But that, unfortunately, people believe them. That the loudest voice, the squeakiest wheel, etc., has the influence. And apparently, yeah. Well, they certainly make the most sound, but also people are listening to them, which is the sad bit.
The thing we found interesting, especially dealing with climate change denialists, they make a lot of noise and they demand equal time. Well, let's have equal time based on scientific plausibility and based on what the scientists say. And if based on that, then for every 99 people who believe in climate change, we should then only have one person who disagrees with climate change, because that would represent the true proportions based on a scientific level.
Yeah, John Oliver did that quite well on the I forget which particular program it was on at the time.
Oh, he stole it from me then.
But he said he must have stolen it from you. He actually he got sick of this idea of a one-on-one, sort of one denier versus one sort of pro. It gives a false impression of the weight of the argument. So he actually brought in 99 other scientists, etc., and to sort of indicate the true ratio of those who support climate change against those who don't. It was a very good visual joke in a way, but it worked well.
Great minds think alike.
Absolutely.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is broadcast on Science Zone Radio by the National Science Foundation in Washington, D.C., and through both iHeartRadio and on TuneIn Radio. Or you can subscribe and download SpaceTime as a free podcast through Apple, Stitcher, Bytes.com, Pocket Casts, SoundCloud, Spotify, YouTube, Audioboom, Podbeam, Android, Castbox, from SpaceTimeWithStuartGary.com, or from your favorite download podcast provider. You can help support the show and the work we do by visiting the SpaceTime online shop and grabbing yourself a few goodies, or by becoming a SpaceTime patron, which gives you access to commercial-free double-episode versions of the show, as well as bonus audio content and other rewards. Just go to our Patreon page through spacetimewithstuartgary.com for all the details. If you want more space time, check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, at SpaceTime with Stuart Gary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to www.facebook.com/spacetime with Stuart Gary. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.